Good morning. This is very important question and an expected one. Let W be the subspace of 4-dimensional vector space generated by these given vectors, and we have to find the basis and dimension of W, the subspace W. Also extend the basis of W to a basis of whole space R4. What we have to do is, first we need to find the basis of W, right? Whatever basis we are getting, suppose we are getting 2 bases. And then we need to extend these bases to the basis of R4. What are the standard bases for R4? It is 1, 0, 0, then 0, 1, 0, 0, then 0, 0, 1, 0, then 0, 0, 1, 0, and 0, 0, 0, 1. These are the standard bases of R4. So we have got the basis for W, and also we are having the standard basis for R4. Together these vectors forms the generating set of R4. Or we can also say that these forms the generators for R4. So there are total 6 elements for these standard bases and also these 2 bases of W, right? So we are getting the generators of R4. And as we get the generators for R4, and from these generators of R4, we get an echelon form matrix, and from that we get the basis of R4. And those bases for R4 are nothing but the extension of the basis of W to the whole space R4. Okay, let's start with the solution. So these are the vectors which are generated by W, right? And now we are going to find the basis for W. Alright, so I have written all these vectors in a matrix form, and these vectors are the generators of W. It is given to us that subspace W is generated by these 4 vectors, right? And from here, now we get the basis for W. I'm already having 1. We just need to make all these entries to be 0. So first we need to make this 2 as 0. For that, just multiply the row 1 with negative 2 and adding these elements to the row 2. So we are going to change the row 2 and adding its elements to the row 1, but row 1 should be first multiplied with negative 2. So writing the first row as it is and applying the operation. 1 multiplied with negative 2, we get negative 2. Adding this to 2, we get 0. Minus 2 multiplied with minus 2, we get 4. Adding this to minus 3, we get 1. 4 multiplied with minus 2, we get minus 8. Adding this to 9, we get 1. 1 multiplied with minus 2, we get minus 2. Adding this to negative 1, we get minus 3. Similarly, we need to apply the operation on the row 3. We need to make this 1 to be as 0. So for that, row 1 should be first multiplied with negative 1 and adding its elements to the row 3. So I am going to change the row 3 and adding its elements to the row 1, but row 1 should be first multiplied with negative 1. So we get 0, 2, 2, minus 6. To get 0 in place of 2, just multiply the row 1 with negative 2 and adding its elements to the row 4. So we get 0, negative 1, and 3. Right? And because all the elements below this element is 0, so this 1 becomes the leading element of the row 1. I'm having the leading entry 1 in the second row. To make this to be a leading element, I need to make all these elements to be as 0. To get 0 in place of negative 2, we multiply the row 2 with 2 and adding its elements to the row 1. To get 0 in place of 2, we need to multiply the row 2 with negative 2 and adding its elements to the row 3. To make minus 1 as 0, multiplying the row 2 with 1 and adding its elements to the row 4. And because all the elements are 0 except this leading entry, so this leading entry now becomes the leading element for the second row. For the row 3, all the elements are 0, so there is no leading entry in the row 3. And also there is no leading entry for the row 4, right? So this is our echelon form matrix. And because these two are the non-zero rows over here, so the basis of W becomes 106, -5 and 011, -3. And what is the dimension of the subspace W? How many elements are present in the basis? 2. So the dimension of W is 2. So we have got the basis for the subspace W. We need to extend these bases to the bases of R4. Now since these bases are the linearly independent subset of R4, right? So these bases can be extended to form the basis for R4. Now to get the generators of R4. These are already the generators of R4. And plus the standard basis for R4, those are also the generators of R4. What are the standard bases? It is 1 0 0 0 and then 0 1 0 0 and then 0 0 1 0 and then 0 0 0 1. So these are the standard bases of R4, right? So these also forms the generators of R4. So R4 is generated by now how many vectors? These 4 vectors and also these 2 vectors, right? So the complete set of 6 vectors forms the generators of R4. So R4 is generated by the bases 1 0 6 -5 and then 0 1 1 -3 and then 1 0 0 0 and then 0 1 0 0, also 0 0 1 0 and at last 0 0 0 1. So these are the generators of R4, or R4 is generated by all these 6 vectors. And from these 6 vectors now we can get the basis of R4, which are the extension of basis of W, right? Okay, let's write all these vectors in a matrix form. For the row 1, I'm having the leading entry as 1. To make this a leading element, I need to get this one to be as 0. Just multiply the row 1 with -1 and adding its elements to the row 3. So I'm going to change the row 3 and adding its elements to the row 1, but row 1 should be first multiplied with -1. 0, 0, -6 and 5. Writing the rest of the rows as it is. And because all the entries are 0 below this leading entry 1, so this leading entry 1 now becomes the leading element for the first row. I'm having 1 to be the leading entry for the second row. To make this to be the leading element, I need to make this one to be as 0. For that, just multiply the row 2 with -1 and adding its elements to the row 4. 0, 0, -1, 3 and writing other rows as it is. So now this one becomes the leading element for the row 2. Moving on to the row 3rd, I'm having -6 to be the leading entry for the row 3. Also -1 is the leading entry for the row 4, and because I don't need the negative elements to be the leading elements of the row, I need to avoid these 2 elements. For that, I need to make these elements to be 0 first. Let's take the help of the row 5. For that, I'm taking the help of the row 5, just multiplying the row 5 with 6 and adding its elements to the row 3. Changing the row 3 and adding its elements to the row 5, but row 5 should be first multiplied with 6. Similarly, we can also change this -1 to 0. For that, just multiply again the row 5 with 1 and adding its elements to the row 4. So I'm going to change the row 4 and adding its elements to the row 5, but row 5 should be first multiplied with 1. So I get 0, 0, 0, 3 and writing the last row as it is. This is an important step to notice. To avoid the negative elements to be the leading elements of the row. So we are having 1 to be the leading element for the first row, 1 to be the leading element for the second row. Alright, in the third row now we are having the leading entry to be as 5, right? But we are having a choice that we can interchange this third row with this fifth row and this fourth row with this sixth row. So the operation is, I have changed the row third with row fourth and the row fourth with row 6. So now this becomes the leading element for the row 3 because under this element all other elements are 0, right? Okay. To have this to be the leading element for the row 4th, I need to make these two to be as 0. For that, if I multiply the row 4th with -5 and adding its elements to the row 5th, so I get 0, 0, 0, 0. And also if I apply the operation multiplying the row 4 with -3 and adding its elements to the last row, that is, I need to change the row 6 and adding its elements to the row 4, but the row 4 should be first multiplied with -3. So we get 0, 0, 0, 0 added the last row. So we have got this to be our beautiful echelon form matrix. And I'm having these non-zero rows, 4 in number. So the basis B1 becomes now 1, 0, 6, -5, 0, 1, 1, -3, 0, 0, 1, 0 and 0, 0, 0, 1. So these forms the basis for R4, which is an extension of basis of subspace W. And also these bases are linearly independent, as none of the vectors are linear combinations of the preceding ones. Alright, thank you.